Hello, students, and welcome back to class. In this video, we're going to work on solving and graphing linear inequalities. Before we do, let me thank you all for all of your hard work. None of us signed up for an online class, and yet here we are, and we're making it through together. Keep up all the good, hard work. In these problems on linear inequalities, we are to do three things. We are to solve, graph to show our solution, and then write our solution in interval notation. Let's try an example. First step is to solve. Let's get the x by itself. To get the x by itself, let's get rid of this 2. The inverse of subtraction is addition. I'll add 2 to both sides. Negative 2 and positive 2 is 0 plus 1x. Negative 7 and positive 2 is negative 5. And I'll copy the inequality symbol. What numbers make this true? It is any number that is greater than or equal to negative 5. I've completed the solve step. Now let's graph my solution. We'll do that on a number line. I'll put 0 here, positive numbers this way, negative numbers this way. Let's put negative 5 about there. Now what numbers am I to cover up on my graph? I'm to cover up all numbers that are greater than negative 5. That would be all numbers this way. I'll make the things that I'm covering up really bold so they're easy to see. Now I also want numbers that are equal to negative 5, which means I color in this dot. I've covered up all of the numbers here from negative 5 and bigger than negative 5, because numbers that are bigger than negative 5 or equal to negative 5 make this inequality a true statement. The last thing I do is show this solution in interval notation. Well, what have I covered up on my graph? I've covered up everything from negative 5 through infinity. The negative 5 is colored in, which means I want it. There was an equal bar. So I put the strong bracket on the negative 5. We can never get to infinity, so that gets the soft parenthesis. Let's try a second example. Step number 1, solve. Get x by itself. The inverse of multiplication is division. Negative 8 divided by negative 8 is 1 times x. 6 divided by negative 8 is negative 2. But don't forget one of the rules of inequalities. When you multiply or divide both sides by a negative number, this symbol flips over. All numbers that are less than negative 2 will satisfy this inequality. Let's show that on a graph. I want to cover up numbers that are less than negative 2. Let's put 0 there. Negative 2 would be about there. And my job is to cover up all of the numbers that are smaller than negative 2. That would be numbers this way. When I'm covering up these numbers, make the arrow big and bold like that so that I can really tell I'm covering up things this way, not things this way. Now this time there's no equal bar, so we leave this dot open, showing that I don't want the negative 2. I only want numbers that are less than negative 2. As an interval, what things have I covered up? From left to right, I've covered up everything from negative infinity all the way up to negative 2. I did not color in the negative 2, so soft parentheses there. And I can never make it to negative infinity, so soft parentheses there. If this were an equation, the first thing I would say is I don't care if I end up with x on the left or x on the right. But in an inequality, things stay clearer if we end up with x on the left. That way, this arrow will be pointing the correct direction when we go to make our graph. I want to end up with x on the left, not on the right. So let's get rid of this negative 2x. The inverse of subtraction is addition. We'll add 2x to both sides. 4x plus 2x is 6x. Copy the minus 1. Copy the inequality symbol. Copy the 3. Negative 2x and positive 2x is 0. To get x by itself, we should get rid of this 1. The inverse of subtraction is addition. Negative 1 and positive 1 is 0, plus 6x. 3 plus 1 is 4. Now divide. 6 divided by 6 is 1x. And 4 divided by 6, well, that doesn't divide very nicely, but I can reduce 4/6 if I divide by 2 and divide by 2, reduces to 2/3. Let's get my graph ready. I'll put 0 here. 2/3 is less than 1. Let's put 1 out this way. This would be 1, 2, 3, 4, and so on. 2/3 is between 0 and 1. It's a little closer to 1. We'll put 2/3 about there. I want to cover up numbers that are less than 2/3. That would be numbers this way. I also want numbers that are equal to 2/3, which means color in the dot. I've covered up all numbers that are to the left or less than 2/3 or equal to 2/3. All numbers that are less than 2/3 or equal to 2/3. As an interval, what have I covered up? Well, as I go from left to right, I've covered up everything from negative infinity all the way up to 2/3. The 2/3, I've darkened in the circle because of the equal bar. That means heavy bracket here. I could never make it to negative infinity. Soft parentheses there. Here's one last example. Let's start by distributing on both sides. Distribute the 5 times 2x times negative 4. Now distribute the 4 times 3x times negative 1. Again, if I have x's on both sides of an inequality, things stay clearer if you end up with x on the left, not on the right. Let's get rid of that positive 12x with a negative 12x. (10x minus 12x is negative 2x. Copy the minus 20. Copy the inequality. 12x minus 12x is 0. Copy the negative 4. Now we'll get rid of this 20. The inverse of subtraction is addition. Negative 20 and positive 20 is 0 plus negative 2x. Negative 4 plus 20 is 16. Finally, we'll divide by negative 2. Negative 2 divided by negative 2 is 1x. 16 divided by negative 2 is negative 8. And remember, when you divide by a negative, the inequality flips over. Let's get a nice graph of that solution. Here's my number line. Here's 0. Positive numbers this way. Negative numbers this way. We'll put negative 8 here. Now I'm to cover all numbers that are greater than -8. From -8, here are all of the numbers that are greater than. Make that bar nice and bold. Big arrow on the end. But there's no equal sign, so don't color that in. As an interval, what have I covered up? From left to right, I've covered up everything from -8 through infinity. But I didn't cover the -8, soft parentheses, and I can never make it to infinity, soft parentheses. All right, these look great. Go work some homework problems. I'll see you later on today.